Okay, my new 350 watt Chinese made motor, DC permanent magnet motor is in. Just got it in. I'm gonna do a few tests here with these drills. Just what's going on here? Okay, yeah, our multimeter. I don't have easy way. I don't have my multimeter. Can't measure DC amps, and my other clamp meter can't do DC amps. Can do AC amps. So we're not going to be able to directly measure full power, but we can get an inference of the power based on the RPM of the motors and as well as what we already know. I know this is a 350 watt DC permanent magnet generator, so it produces direct just by the spinning of the shaft here. We can obviously get current because there's basically permanent magnets in here and then coils, and of course the law of electromagnetics allows there to be electricity produced just from turning this. But I'm going to use this ultimately for a bicycle generator project. I have this one here that I got from a thrift store, and I also have a a trainer that I can use with any bicycle that I can adapt. But that's coming later. First, we're going to do some demonstrations here. We have this AC 110 volt hammer drill, and that is rated at 6 amps, so it's about 600-700 watts of power. And RPM, it can go up to 3,000 RPM. And so, FYI, this can't remember the name of the electrical law, but it basically there's a law in physics and electromagnetism that says whatever this motor is rated at, you can get by doing the inverse of it. I think it's like Lay's law. Forgive me, I'll post it. But anyway, so this is 2700. So this is much stronger here. Not much stronger. I can burn this out by going full speed on this right here because it's only rated for 2700 RPM, 350 watts. And this is rated, this as a motor up to 700 watts. Okay, and so we're going to do a little quick demonstration and see how much power. And then I've got these two DC drills that I'll show you here. And this one here is a Harp 20 volt, and it is rated at, sorry, it's really, I don't know why it's not focusing. Okay, there we go. So as you can see, it has two speeds. In the first gear, it can do 400 RPM. In the second, it can do up to 600, and that's at 20 volts. And so there's an inference. You can get the watts without knowing the amps directly, which I'll post. And this one is about, this can also do 600 RPM maximum, but that's at 12 volts, right? So we're going to do some quick demonstrations here. Okay, so hopefully you can see that multimeter in volts. And this, like I said, this is the 12 volt drill at 600 RPM. So I'm guessing, top of my head without doing the math or the formula, it's probably something like 150 watts or something. But let's see how many volts we can get out of this generator. Shaking, but you can see about 4.5 watts. Sorry, not watts. 4.5 volts out of 24 volts motor. So we're getting about, that's about right, So we're getting about, a fifth or a sixth of the potential of this generator with this. Obviously 600 RPM versus 2700 motor. So that's about right? So something ballpark expected, 4.5 volts. So with that, I reckon with this one, we should deduce, because we're double the power. Remember, this is a 12 volt motor, and this is a 20 volt motor, and maximum 600 if I do it in second gear here speed RPM we can get. So we should be able to at least get 9-10 volts from this. But let's see. Okay, I'll make sure it's tight. Okay, all right. I'm just gonna do it in second gear. I know first gear I've done a test before. It's less than this because it's only 400 RPM in first gear, but 600 RPM at 20 volts. Let's see how much we can get. There you go, 12.3 volts. Almost enough to do a charge. Oh, sorry. It got loose here. The check got loose, but you saw that. 12.3, 12.4 volts at 600 RPM. So about half the potential of this motor here. And with this motor alone, if you can spin it, therefore, reasons to say that if you can spin this at 600 RPM, with a bicycle generator with a gear problem, you can get it up to that speed. You can get about 12.4, 12.5, maybe in fact, just enough to charge a 12-volt battery, you know, not really ideal. You really want 13, 14 volts for 12-volt systems. But anyway, next test, we're going to hook up our AC. And this one I just got to be careful because like I said, it's 6 amps at 600 RPM. So it definitely can put a lot more power. We know that it's rated 600-700 watts, where this is only 350 watts. So we don't want to blow this motor necessarily by running it too long or hard. But I just want to show you here our demonstration. Okay, not the best test conditions, I admit, but just so you can see. All right, I'm gonna do this now. Yeah, so yeah, easily can get 20 volts. 20 volts. Okay, we got 21, 22 volts, and I believe that's not even maximum speed, and that's actually, I don't want to go to the push to limits, but I'm sure I can get more than 24 volts from this motor here. So easily I can reach the 350 watt potential of this motor with this 700 watt drill plugged into the wall. But of course, we're not going to be using this or this or this when we really utilize this generator. We're going to be using human power. We're going to probably not use this one. I might do this. This will be a good indoor generator. It's got the computer and everything with it already. Or I can even hack the computer, maybe take some of the magnets or something, do something with that. But originally my idea was to convert this one here, this trainer, because this can be used with any bicycle and it's not fixed. The problem with building these other bicycle generators where they're fixed for this one use, whereas this I can use any bicycle, and I can use the bicycle as a bicycle, and then when I want to bring it indoors or whatever exercise in the generator, I can use this trainer. This basically has a flywheel. So I got this for 35 bucks. I know it sounds expensive for a thrift store, but hey, it's worth it. There was actually a housing, which I've already removed. There was this housing. It was all part of this, and this is actually, there's this 2 magnets here that's used for the resistance, but they're pretty strong magnets. So I'm kind of hesitant in using it with the, basically because I have these strong magnets and these housings. I'm tempted to actually learn how to wire a motor properly and build my own custom permanent magnet motor with this setup as is. But otherwise I can just basically convert and adapt this, make a stator with a gear ratio that, and a chain or a belt to that DC motor as you saw, and use it as a generator. So based on the size of the wire, basically, so the math is here, and I'll try to go through it really quickly, really roughly, of the theory behind it, is basically as a bicycle, like a normal bicycle, like a mountain bike or something like that, I can expect to be able to pedal reasonably as a human anywhere from 50 to 100 RPM. So yeah, you might be thinking, wait a minute, you just said you can pedal about 50 to 100 RPM on a bike, but you are only able to get, 12, 13 volts, up to 20 volts with the really, really high power drill at 600 RPM. So where's your math at? Well, basically, when you say that pedaling at the standard cadences for a human getting 50 to 100 RPM, we're talking about a wheel this size, right? So this is like whatever, 28 inches, or is it 30 inches? I'm not quite sure here. And that's the RPM we're talking about. But all of a sudden, when you convert that RPM to a rotor that's much smaller, like this, for example, this is 2-inch rotor, right? So just with that example, let's just say 20. Let's just say a 20-inch bicycle down to 2 inches. So that's a ratio of 10 to 1. Right, so basically the very rough math, and correct me if I'm wrong for any mathematicians or physicists out there, a 10 to 1 ratio of, let's say, even if I was like a super Olympic guy getting 100 RPM, just to keep the math simple, on that bike, 100 times 20, that's 2,000 RPM. So that's, pushing towards what we were really looking for from that 350 watt generator. So that reasons to say we can get up to, 200 watts, 150, 200 watts in a perfect ideal scenario. But, in reality, I'm probably only going to be able to get 50 RPM at a steady rate 40, 50 RPM on this for, good, because you want to charge something for at least a half an hour. So a good half an hour workout at 50 RPM. And let's say our ratio conversion is only 10 to 1, So even at 50 RPM, we will be able to get 10 to 1 with all the losses and everything. 50 times 10. Well, what is that? 500. 500 RPM. So we get pretty close to that drill, depending on our power and the resistance we're going to reach. So we're going to be able to at least get 12, 13 volts theoretically. And I'm obviously being very conservative here in these calculations. And the ideal conditions and the ideal minimized losses, I'm sure I'll be able to get upwards of 150, 200 watts at that little 350 watt generator, maybe more. I have built a permanent magnet generator with a similar motor many years ago, but I didn't have any trainer like this, so I had to build my own little stand and an old bicycle conversion, and I was using belts, and even that, I believe I was using a 200 watt motor. This is a 300 watt motor, and I was able to get 15, 17 volts out of a 24 volt motor as well. It was 250 watts. It wasn't too hard, so I was able to charge up some stuff. So I think with that experience and my improved knowledge and understanding of all the physics behind it, and what I need to do to optimize the build here, the design, that I'll be able to get upwards of 150, 200 watts of power. But even if I get 100 watts, and I can sustain 100 watts of charging for half an hour, that's more than enough to charge a lot of things, And besides, the point isn't necessarily just because I'm needing extra power or something like that. And obviously I can just get a windmill and not do any work. But the point is, I see people, I don't really understand why people, why they have all these trainers, and these people are very serious about just like driving their bike. No, we're obviously in colder countries in the winter and they can't necessarily take their bike out, and so then you keep in shape and stuff. But if you're going to do that, why not? I'm sure many people have thought of this. I'm not the only one here. That why not just build a bicycle generator, use the bicycle, you can use the same exact setup, the bike you love, get something like this, do the conversion that I'm about to do, and then, have a power control system and charge your phone and everything. I actually have ideas and plans in the future that I think in the future, like if I built a resort or anything like that, rather than just like charging customers a premium for the electricity or whatever, or calculate it in there, it'll be off grid 100% completely, and they'll have a little micro workout gym, or maybe it'll be a central one where everyone can go and they can earn their credits, basically by working out and feeding back into the system. And then you basically simulate a credit scheme where if you do a lot of work, then you can use a lot more in the evening, relax, whatever, something along those lines. Obviously needs a lot of refining and critical thinking, but anyway, I'm looking forward to this project, so stay tuned.